Welcome everyone. So in this episode /video, I wanted to go through the specifications of a new wearable device for research called Fibion Vitals. So it's measuring a lot of signals. It has a 9D motion sensor, meaning accelerometer, gyroscope, magnetometer. It's measuring one lead ECG. It's measuring impedance of the chest cavity, so it can detect respiration. There's a temperature sensor. It has a sound pressure sensor. So let's look more into the specifications, how it's measuring, and what are the other specifications of the device. And it can be used for sleep research, but also for physical activity, exercise science, and the main point is that it can measure a lot of different signals easily in normal living environments, whether it's sleeping at home or doing things outside or at home during waking time. And if we start from the signals, so it has an acoustic signal, so basically it's measuring sound pressure, and it's doing it in a transmission frequency of 100 to 10,000 hertz, and the range is from 30 to 120 decibels, and the resolution is 16 bits and sampling rate is 20 hertz. So it can measure nicely the sound pressure, and for ethical reasons it's not recording the sound itself, so you cannot detect, for example, what people are talking from this signal. So it's good in that sense that it provides information, but it doesn't cause ethical problems. And from the acoustic signal, especially when we combine it with the movement of the chest, and we can detect, for example, snoring and coughing from the signal. It can be used also for other things if needed. And then if we look at the ECG signal, so the measurement range is plus minus 0.8 volts, and it's the normal range for electrocardiogram signal. And the accuracy is 16 bits and the sampling rate is 250 hertz. So that we are able to get the full accurate curve of the ECG, we need quite high sampling frequency, so it's measuring at 250 hertz. Then it's the heart rate. It's written pulse here. Basically, that's a little mistake. It's more like heart rate. Pulse is more measured from the distance of the heart, and the range is from 20 to 330 beats per minute. So should cover basically all the humans and most of the animals also. The resolution is plus minus 1, accuracy is plus minus 1, and sampling rate is 1 hertz. So you should get the good ECG and good heart rate readings. And of course, when we are measuring ECG with 250 hertz, we also get the good heart rate variability with high accuracy when we are sampling at the high rate. And it also has airflow sensor. So if you are using the nasal cannula, you can measure the differential pressure, and this is usually used in a sleep measurement, sleep disordered breathing. But I could see that it could be used also in, for example, sports science applications where you are interested on the breathing patterns of the for example athlete. How do they breathe through the nose in different situations? So it could be used also for such things. And the measurement range is plus minus 500 pascals, and resolution is 16 bits and accuracy is 3% or 0.1 pascal, and sampling rate is 10 hertz. So we can get pretty nice curve of the airflow from mouth or nose. And then it also has impedance measurement. So I showed before that it has the electrodes in the bottom of the sensor, so those will be against the skin, and we can measure the impedance of chest cavity, and when we breathe, the impedance is changing. Impedance of the chest cavity is changing because the air is filling the lungs, and the shape of the chest is changing. And the baseline impedance is 0 to 10 kilo ohms, and it's presented variations around the impedance in the range plus minus 32 ohms. And resolution is 16 bits and 0.001 ohm accuracy. And the sampling rate has been set to 62.5 hertz. So we have optimized the sampling rates that we are high enough, but we are not wasting battery and memory with the kind of overkill sampling rate. It's just high enough to capture those things well enough. And the respiratory movements are measured at range of 0 to 50 beats movements per minute, and the resolution is plus minus 1 beats per minute, and sampling rates is at 1 hertz. And then if we look at the 9 axis or 9 degrees of freedom movement sensor, so it has accelerometer, gyroscope, and compass. Accelerometer has been set in the default is plus minus 2 Gs, and as it's attached to the chest, the torso of the body is accelerating slower than, for example, the limbs. So that's why it's a little bit lower range. And of course, it's a compromise between range and accuracy. So when we have a certain resolution, like 16 bits, when we have the smaller range, we have more accuracy within that range because we have certain amount of data points within that range. So sometimes people think that it's better that if you have a higher range, but when you increase the range, you are losing accuracy. So it depends on the things you want to measure, but basically this one is good because then we can also detect tiny chest movements, for example, during sleep, and detect different things from the chest movement. And the gyroscope is the measurement range is plus minus 250 degrees per second, and the compass is plus minus 4,900 microteslas. So normal ranges for gyroscope and compass. And for all of those, the resolution is 16 bits, so we get the high accuracy for the signal, and the accuracy for accelerometer plus minus 0.5 G, and for gyroscope plus minus 1.5%. And these are sampling at 33 hertz. So it should be enough for most of the applications. And like I said, it's attached on the chest, and our torso is not accelerating as fast as for example, our limbs, especially the distal parts of our limbs. So it should be capturing normal daily life. If you would be measuring, let's say, a javelin thrower from the wrist, probably it would not get the full acceleration, but for normal daily life from the chest, the sampling rate should be enough for most of the applications. And then it has a skin temperature. So the good thing about this skin temperature measurement is that it has the electrode on the bottom of the sensor. So basically it is measuring the actual skin temperature. Quite many devices have the temperature sensor inside the device. It's usually combined with the accelerometer component. So it is more measuring just the temperature of the device itself, which is affected by the skin temperature, but also outside temperature, and it's a little bit difficult to interpret the signal. But when it's against the skin, we get a good measurement of skin temperature, and the measurement range is from 34 Celsius to 41 Celsius, and accuracy is 0.1 Celsius, and sampling rate is 0.1 hertz. So we get the number every 10 seconds, which should be enough because the skin and body temperature is not changing that fast. And if we then continue, we have also integrated the pulse oximeter. So you wear it on the wrist, and then you have the sensor on the fingertip. So this is especially for sleep disordered breathing, that we can measure what is the oxygenation level of the blood. And for this, the measurement range is 70% to 100%, and accuracy of saturation measurement is plus minus 2 units. Let me take that one again. So accuracy of saturation measurement when it's between 80 to 100% is plus minus 2 units, and when it's between 70 to 79%, it's plus minus 3 units. So it's the accuracy is optimized more for the range from 80 to 100. And basically this, that we how we have integrated this sensor is that it's streaming the data automatically via Bluetooth to the same app, to the same cloud. So basically it's an external device, but the data will automatically go in the same place and will be synchronized well with the other signals. And then maybe quickly going the technical parameters. So operating temperature is from 15 Celsius to 40 Celsius. And the storage and transport temperature can be from minus 25 to 70. Probably not the best to keep it at minus 25 for the battery reasons. Permissible humidity is 15 to 90% without condensation. So you can use it in quite a wide range of situation. But yeah, 40 degrees is the maximum, so maybe not best in the tropic. Maximum altitude is 2,000 meter above sea level, and current consumption is 10 microamperes, and input current is maximum 500 microamperes. And it has a lithium polymer battery, which is giving the currency of 3.6 to 4.2 volts. And the dimensions are 66 millimeter to 23.5 millimeters. So it's a little bit larger device, but measuring a lot of signals for that size. And the weight with battery and belt is 77.5 grams. And the accuracy of internal clock is plus minus 1 second per month. So it should be accurate enough for all the normal daily life measurements. And operation time is approximately 48 hours of operation on fully charged battery and measuring all the signals. It can be longer. We have been measuring ourselves 72 hours, so it can be also longer. And recharging time is up to three hours, and the expected operating time of the battery is 12 months if charging quite often. And the enclosure, the cover of the device is biocompatible material, so it shouldn't do skin irritation. It's according to the ISO standards. And the Fibion Vitals works with smartphone or tablet with broadband internet access and at least 1 GB of RAM, and it works on Android and iOS devices. So Android should be newer than version 7.1 and iOS newer than 12.2. And yeah, so that's basically it. So that's the specifications of Fibion Vitals device. So if you are interested on the device, you can check our website at web.fibion.com/Fibion vitals, and you can see more. And if you're interested, you can book a video call with me or Miriam to discuss about the solution and how it could fit into your projects. So thanks for watching, or thanks for listening. Have a brilliant day.